So now, so here, very, very tricky. Now, the how to program in machine learning, right, or how to develop in machine learning is completely different from how you do your normal traditional programming, or how you even think about it, right? So now, you guys have played this game before, right? The brick game or something like that. Then aha. So how do they program something like this? They don't use machine learning. It's just normal programming. So they have to think about it in some sense, right? So they need to actually define some rule. So in terms of programming, if you're doing normal programming, you have to define a set of rules for your program or what you're exactly going to do. So right, if you take this game like this, right, what they first of all do is that they have layers. So you see that there are about three layers here. Then you see that each layer has a brick, and then the brick has different color. So what simply they do is that, so if it hits probably the blue color, right? So what should they do? Once the ball collides with the blue color, it will change direction. The direction can be here or here, right? It can go here or it can go here. So the program, in a sense that if it hit the blue color, it always goes here, and then the speed also changes, right? So if it hits the blue color, change to this direction. If it hits the red one, change to this direction. Understood? And then after it has changed direction, the brake is actually removed. Easy, right? So that's how you think about it. So you define a specific rule. The rule is that if it hits the brake, the ball will have to change direction. And then if the ball changes direction, so it depends on the color of the brake it hits. The direction will be either here or here. It depends. And then the speed will also change, right? And then the brake will be removed. So that is a set of rules we use to program something like this. But you see that this is, and then if you are doing this, so it means that if ball hit this, else if ball hit, else if. So as the number of layers and then the number of breaks increase, your program becomes bigger and bigger and bigger. So we have a limitation here. You can go about probably 1,000 breaks. If you want 1,000 breaks, it means that you have 1,000 if else. So mean that your code become too huge that it is impractical to actually implement. So, so in effect, for traditional programming, you give it rules, specific rules. The rules are hard coded, like you hard code the rule. If this else, if this else, if this else. Then after you have done that, you now give it the data, probably the ball. They give you the data, and then the ball will now give you after that. Once the ball hits here, so the answers are change direction and then remove a break. Understood? So in traditional programming, you have rules, you have the data, and then you have answers, right? This you can do this in terms of machine learning, right? So now here, for instance, there is some kind of there are some kind of activities and some kind of applications you can program using the traditional method, right? For instance, if I want to measure the activity of a human, right, I can give that human a sensor, and then the sensor can easily measure the speed, right? You have sensors that can detect speed, how fast you are moving. That is easy, right? So I can use this speed to actually program, and then tell if that human is walking, is at rest, or is biking. So I can just say if the speed is less than 4, then the person is walking, let's say 4 miles per hour or whatever. So if it detects in the sensor and then it sees that the sensor reads 4 miles, less than 4 miles per hour or something like that, that means that the person is walking. That's easy, right? Now you can also detect if the person is is running. So if the speed is, if so, first of all, so it means that you must always add to your code. So if you write if the speed is less than for the person is walking, so it means that if I want to detect if the person is running, I'll have to write if the speed is less than 4, the person is walking, else is running. Easy. If something is less than 4, it means that the next thing is else it is greater than 4, right? So if the speed is greater than 4, then the person is actually running. But again, you can also detect if the person is biking. You can add a biking to it, not just running. Understood? So we can say that if the speed is less than 4, then the person is walking. Else, if the speed is less than 12, then the person is running. Else is biking. So it means that if the speed is greater than 12, the person is actually biking. Right? But how do you detect for golfing? If somebody is golfing,
I don't know how often that is, but they are able to detect
eh?
whatever you are like. So the moment I pick bicycle, I get to the location you are riding.
Mm,
If I am in the third wheel, you get that notification. I don't
that
know how they do
yeah, sometimes they use all the sensors. So this one I'm using only the speed, only the accelerometer or something like that. So now with your case, it has the blood pressure sensor. It has all of that. It has the heartbeat
the
sensors.
velocity, the movement of your
Yeah,
arms.
yeah, yeah. It has everything. It has a lot of sensors, so it can detect a lot. Right? So now let's say I'm just using the speed. Can I detect golfing if I'm using just the speed? So you see that
It's not possible.
it will be some kind of way. So using the traditional method of if else, it will really work here. Right? So for the for the machine learning, right? Instead of you giving it the rules, right? What you do is that you give it the answer and then you give it a data. You give it answers, you give it data, and then you let the machine learn. And then the machine will now make its own rules. Understood? So you give it the data, and then the data probably let's say I want you to detect a cat or a dog. I give it the data is the cat and the dog images, and then I give it the answer. So I take each cat image and then I label it. This is a cat. So I feed this one. I say, oh, machine, this is a cat, and then the machine will now take that data and that label and then it will learn. It will find some pattern and say, oh, anytime it sees some kind of pattern, this is a cat. And then I feed it with images of a dog. And then it tells itself that, oh, anytime I see this pattern, that's a dog. So it creates its own rules. All you have to do is give it the data and then the answer. And then the answers are just labels. The data is, let's say, the image of a dog. The label is, this is a dog. Understood? So the machine or the algorithm makes its own rules by itself. So in that way, for instance, if you take something like this, if you take something like this, right? You take all the sensor values, right, and then you label them. So this is the data is here, right, and then you have the label. So you say that the machine, if it sees this kind of data, right, the label is working. Now, if it sees another kind of data, then the label is what? Running. If it sees another set of data, then the label is biking. Then if it sees another kind of data, the label is golfing. So what the machine does is that it takes all the data, then it looks for differences between all the data. Then it will spot it on its own, right? For instance, it will see that, oh, the last line, like 1, 2, 3, here is different from this one. You see that here it's 1001, right? Then this one is 111, right? And this one is 1011, and this one is what? 110. So the machine learns and picks a pattern that, oh, anytime it sees this one, anytime it sees 101 over there, it is working. Anytime it sees 111, it's running. Anytime it sees 1011, it's biking. Anytime it sees 1110, it is golfing. Right? So you see how the machine learning algorithms work.
Why is it taking all the time?
Yeah, because it is learning the rules on its own. So nobody is teaching it.
Basically,
So this is an example I'm just showing. I'm not saying so the pattern it picks its own pattern that is completely different from another set of labels and then their pattern.
And so you don't define the pattern for.
No. It does its own. All you have to do is give it the data and give it the label.
okay, so basically, you give it the data,
The what?
you give it the data with the machine.
Uh-huh.
You give it the data
Yeah.
and the actual task you want it to
Yeah.
work
So
for you.
that task is the label
Then it will generate a pattern
on its own.
on its own.
It is really planned for each activity or for each. So like for here, I want to detect walking, running, biking, golfing. So I have to give it a set of data and then label the data walking, right? So and then it is not just one data. Oh. So I have to give it however a human being works. So some of them work some way, some of them work, and I see some of them are stone boys kind of working, and stuff like that. So
Different kind of
different
working.
forms, and then label it working. So it will learn everything, and then it will see some patterns that if the person is working this way, and then somebody is working this way, but it's still working, right? It sees some pattern. You say, there's something common between them, and then if a person is running, it always sees something common. So that is the rules. It is generating rules for itself. You don't define those rules.
After it generate the pattern, they see the differences between the pattern and it will set it through. So you, when you are to ask you,
Aha. So
input, then it will give you
and
the
then so after you have trained, what we are doing is training. So it has trained itself. So now all you have to do is give it a data, and then it will say, oh, this data means that it is working. This data means that it's golf, and this data. So let's close here.
Alright.